Hello student, in this lesson we are going to solve natural logarithmic equations and inequalities. So the question here is solve each equation round to the nearest 10,000. So you have ln of 5x equals 4. This is your original equation. Now to solve that we have to write each side using exponents and base e. So I'm going to bring this to the base e and e to the other side. So we said that logarithmic functions, they have inverse exponential functions. The same thing applies here. Natural logarithmic functions have the inverse natural exponential functions, so they cancel each other. So e and ln, they cancel each other. So what's left is 5x equals e to the power of 4. So here we are going to use the inverse property of exponents and logarithms. Inverse property says that to leave x alone, we have to divide by 5 both sides. So 5 divided by 5 is giving me 1. So x is approximately 10.9196. For that you have to use calculator and check that using substitution or graphing. We said that the question is we have to round the number to the nearest 10,000th. Remember, 10,000 is supposed to be 4 digits after the point. Since you start with a tenth, hundred, thousands, and 10,000ths is the last digit. So we're going to get only 4 digits by applying the rule that we know, taking the fifth digit. If it's greater than or equal 5, you add 1 digit to the previous digit. If not, you leave the answer as it is. Now, this is method 1, and I'm going to try to explain you another method to solve this kind of equation. So again, I'm taking the equation ln of 5x equals 4. So in this case, I am going to use definition of logs, thinking that logarithmic function and natural logarithmic functions are the same and they use the same properties. So the base for ln functions, which are our natural log functions, is e. So we are going to use the definition of the log. E to the power of 4 gives me 5x. So I go back and I write e to the 4th power equals 5x. In this case, to leave x alone, I have to divide by 5 both sides. Now you can see that we came the same equation like before. We said to leave x alone, again we have to divide by 5. So the answer is going to be 10.9196. Which one is the same answer as we said before? Now I want to review in this case why we are eliminating here is and ln. Since the natural base functions and the natural logarithmic functions are inverses of each other, I'm opening a little space here, these two functions can be used to undo each other. So what do I mean with that? So if I have e to the power of ln x, they undo each other, e and ln, so the outcome is x. Also, if I have ln e to the power of x, ln and e undo each other, so x is the outcome. I'm going to show you 2 examples. If you have e to the power of ln of 7, so we have e and ln, they undo each other, so the answer is 7. And if we have ln of e to the power of 4x plus 3, okay? So again, ln and e, they undo each other, so the answer here is 4x plus 3. Okay, I'm putting the 3 down since I cannot write there. So you can see that we are applying here the inverse property of the function. When the functions are inverse of each other, they undo each other. And what get in this machine of 2 functions is x again, because after undoing each other, the x is the origin of the functions. So this is a lesson showing you how to solve natural logarithmic equations and how to use important property like definition of logs, inverse properties of exponents, and using another strategy that you remember here, we said in this case we take e to the power of ln, e to the power of 4, so we bring everything, we write both sides using exponents base e. And we do this for a reason that I explained to you, because exponential functions and logarithmic functions undo each other because they are inverse of each other. Thank you.